Now we're going to look at quantity takeoffs and what to do and how to assemble a problem statement similar to this. So we have a 450 foot length canal is to be lined for concrete erosion control. For erosion control. Now, with a 10% waste and overbreak. Now, if you don't do this every day, be very, very careful. What I've found through the years is that people forget 10% waste. Right? They do the calculations. It's perfect. The calculations are perfect. But you forget about the waste. So you got to flag it for yourself. Whatever you need to remind yourself that it's got to add 10% waste. So you're going to add the waste where it's needed. Okay? And the material unit cost for the concrete and the curing compound based on other recent projects in the area with similar volumes is $98 per cubic yard and $40 per 5-gallon pail of the curing compound. Okay, so what we're seeing here is that we have the concrete, and when you're given units such as this, it's $40 for a 5-gallon pail. It does not mean $8 per gallon. Okay, careful with this. You can only buy a 5-gallon pail. So if you needed a half gallon, well, you got to buy 5 gallons. It's going to cost you $40. It's not going to cost you $4. Okay, so be very careful. You cannot change anything because this is a national exam and everybody's looking at the same information. So you can't change things simply because you feel that, well, it's going to cost you more and you don't like to waste money. This is not your job. This is an exam, and that's the key to your analysis. So your project specifications require an application rate of curing compound at $1 1 gallon per 300 square feet. So let's analyze first the figure and let's see what we're actually doing here. So we have the concrete. I'm going to enhance the concrete with my yellow pencil right here, and the yellow pencil indicates that that is 8 inches thick of concrete. Okay, so that's basically what we're putting down, 8 inches thick of concrete. And we're also given the slopes of this. We don't know what this is, but it's H to V, similar to what we did in the previous example, or X, Y, same format. Engineers use X, Y, H to V. They don't go VH. It doesn't happen. It's always X, Y, that format. And so in the X direction, it's 3. And in the Y direction, it's 2, right? So H to V is 3 to 2, or as shown here. So that slope of the line is as shown. And we also are given some dimensions. So we have 19 feet here at the base, 20 feet here. And so we're seeing that we have to do some geometry. And more important, though, is conceptualizing the problem and making it a 3-dimensional object for yourself. Okay, so it's a 450 foot long canal. So what does that mean? Well, you can make it a 3-dimensional object for yourself, right? So look at it from a 3-dimensional point of view. Okay, so that's basically what we just did. So it's 450 foot long. Okay, let's stretch that out, make sure we understand that. So we have 450 feet. All the rest of the pieces are there. We're ready to now tackle it from a point of computation. So we have the horizontal length of the side slope is 30 feet. Well, what does that mean? Well, we have to find the geometry of the shape. And similar to what I just did on the previous page, right? The yellow is what we're looking for. And so if we go down, okay, that's where we have that H to V, right? So we're multiplying this. So if it's 20 feet, right, we know how we're pulling all this together. If it's 20 feet deep, and so if it's 20 feet deep, we're going to go over 30, right? So that's 30. So we have a triangle now formed, and so we have to find the hypotenuse. So the slope length is 36 feet. So that's 36 feet based on the slope on both sides, right? So that's 36 and 36. And the bottom is 19 feet. Right, so we did the geometry, we've got our surface, we know what we're doing there. So the entire yellow portion of this is the cross-sectional area, right? And so we add these together, the two 36s plus the 19. And since it's 8 inches thick, right, it's 8/12. 8 inches divided by 12. Yeah, 12 inches per foot. So we're using all of everything. Okay, we're converting everything properly here. We have feet. 8/12 foot, and so that entire area is 60.74. It's 450 foot long. Divide that out, get cubic yards. Don't forget the 10%. As I said, you'll forget the 10% if you're not conscious of it during your analysis. Add that and you get your final answer. Now let's look at the surface area of the canal. The surface area of the canal is when you place concrete, and we're going to review that later on. There's an entire concrete premise, so you're going to see what the definition is of curing compound. But in concrete, as soon as you mix it, the water in the concrete starts to evaporate. And what we do is we want that water and the cement, the Portland cement, to stay together as long as possible to develop the strength that's needed for the concrete. So what we do is we take a curing compound, which is nothing more than, think of it as a paint. We paint the surface, and effectively it slows down the water evaporation. That's all it is. That's all it is. So the curing compound slows it down, and as a result, the chemical bond with the water and the Portland cement happen, and you got strong concrete. So we want to find out what the paint is, and similar to what we looked at before, it's 1 gallon per 300 square feet. What does that mean? Well, it's somewhat similar to if you were painting your house. If you went out and bought a gallon of paint, your coverage for a gallon of paint usually runs around 200, 225 square feet. So this is a lot thinner, which it is. And so as a result, we're painting the concrete after we place it. So we want to know what the surface is. Just think of it that you're going to paint that entire canal. So it's 41,000 square feet. It's 300 square feet per gallon, so you need 136.68 gallons. However, you're not going to forget the 10%. Right, so you have your 10% given to you there. And you can only buy it in 5-gallon buckets. And so here I exaggerate the calculation steps. And in estimating, and we've done this before, you have to round up. Okay, so you're not going to buy 30. Okay, if you're doing this for your house, you're absolutely not going to buy 31 gallons of paint. All right, you're going to save that gallon cost. You have to buy 31 containers. So you're going to have to get it to that point, calculate it out, and get your final answer here. Okay, so that's the importance of what we've got